Then we will switch to the next speaker, which is then Håkan Sundelin from Electrion. He will talk about wireless electric roads ready for large-scale deployment. Please go ahead, Håkan.
Oh, thank you very much. Can you see my screen?
Yes, we can.
And you can see my presentation?
Yes.
Great. Okay, thank you very much. My name is Håkan Sundelin. I'm the regional director of Electrion and also the product manager of Smart Road Gotland. I'm also working with electric roads for about 10 years now. Basically, this installation on Gotland is my third electric road vehicle. I've been working with wireless and also overhead lines previously during my time at Scania, and also been the research or the project leader of the electric road collaboration between Sweden and Germany. But right now, I'm the project manager of Smart Road Gotland. I will tell you more about our technology. Electrion is a Israeli company. I'm in charge of the Swedish subsidiary, which is fully owned by Electrion in Israel, which is also publicly traded on the Israeli or Tel Aviv stock market. We are only focusing on wireless charging and the technology for both the vehicles and the infrastructure. I think I have to thank previous speaker for the good introduction to ERS. So I will skip everything about why we're talking about ERS, but just to mention some, and this has been discussed earlier as well. The challenge in our view is the batteries. If we want to transport long-haul trucks, especially, but also passenger cars, we will need a huge amount of batteries, especially if we're going to go and reduce the fossil fuel emissions. And electric roads provides then a solution in order to remove those batteries and increase the economic and environmental impact. I added a picture since Gios showed a cost comparison, which I wasn't really familiar with. I usually don't compare our technology, but this is a comparison made by the Swedish Transport Administration, and our technology is the one to the right, which I circled, and it kind of differs a little bit from the previous presentation. But it really doesn't matter. I think all different technologies are more or less in the same magnitude. So it's a discussion about how to do it. So why do we believe that electric roads? Yeah, I mentioned battery, the size and weight of it, and but also, and what's often forgotten is that if we're really going to go completely fossil-free, we need to electrify the passenger cars as well, and that is actually a much larger impact on the total environment, because that will need a huge amount of batteries. Even if the heavy-duty vehicle are making up in Sweden a third of the emissions, to electrify the passenger cars will need, I think, 70% of the total amount of all batteries that we would need. So how do we lower that number? And then we see electric roads as a solution. And so why wireless then? Yeah, mainly that we are creating a shared infrastructure so that can be used by any type of vehicle. We are after we have installed it, we have no visual impact. But of course, no one pays us for having that. It's nice to look at, but that also has a large impact on road maintenance and and also keeping the road clear, clearing the sites, since there are nothing to crash into. There's also easier installation. So what we are doing is that we are placing coils into the asphalt. They are powered by a management unit that can either be installed underground or above ground. This underground unit is then feeding. So when you pass with the vehicle, exactly when you are on top of the coils, we activate the coils and transfer energy to the vehicle. And the vehicle then has a receiver. Basically, it's technically a air transformer. So we have half of the transformer inside the ground and the other half on the top of the vehicle, or below the vehicle. And just to give you a view, so what we can do, often we are talking about electric roads now, but we are not seeing electric roads as a single solution. We are doing all of it. So the same technology can also be used in static, or what we call semi-dynamic, or in dynamic mode, and for all different types of vehicles. And so it's not a choice between electric roads and static. It's rather, of course, when you are standing still and loading and unloading, you should charge. You should not stand still to charge. And this is especially true when we're going to a future with autonomous vehicles. Then it becomes kind of ridiculous that you should have to stop the vehicle that actually is designed not to stop, just to charge. What we include in the system is also a management system that we are metering exactly how much each vehicle is consuming, and its location, its state of charge, and thereby we can provide orchestration of the fleets and improve, because the challenge in the future will rather be the amount of energy that is needed to one location, and therefore you need to optimize it. What we also can do then is that we can have a smart balancing of the grid sources, because we will have power shortages in the future as well, and therefore we need to be clever how we divide the restrained resource in terms of energy. And so in this case, when the passenger car or the bus has the lowest amount of energy, we could, in the case of energy restrained, prioritize to charge that specific vehicle instead of the fully charged truck. So we are really, our target or the use cases we are focusing on is cities. Buses are, as you all know, the forerunner in electrification when it comes to commercial vehicles. And then point-to-point electrification of the highways, ports, and industrial zones. And also, of course, autonomous vehicles, because basically autonomous vehicles for commercial vehicles are looking at the same use case as we are. We are right now working on 3 different projects publicly. The one I'm managing is the one on Gotland. So the small island east of Sweden. We are building a 1.6 kilometer electric road. We are actually right now, really very much right now, installing the last section to finalize this during October. And also the bus you see in the picture is actually arriving to Sweden and Stockholm tomorrow. So a lot of things are happening in October. But the truck is already ready, and the first installation was done a year ago. and we had the first test done in February this year. But now we are really looking forward to test the full route. And just to give you a preview of what we're doing, this was the installation done in November last year. So to the right, you see the grid connection, and then you see the actual road installation. So what we do is that we open the road, basically we mill it and prepare the trench. Then we are placing the coils and connecting them to the management unit. And after that is done, we are repaving the road, and then we are done. This was the video here was from the very first installation, and since then we have then tested the system, as I mentioned, in February. We were lucky. Gotland is not the obvious place for heavy snow, but we actually got some snow. So, which is not it's really not an issue. But sometimes I get the question that, oh, will the system works with snow and ice? And but technically, it's a stupid question because it's a magnetic field. It doesn't have interference with water, snow, and ice, and as long as you don't mix it with steel. So it worked. So, but it was good to be able to test it on also on winter conditions. For the next installation that is being done now, we are supplying the next section with a energy storage that we power partly by solar cells. This is mainly done to show that it can be done, because one of the questions we also often get is that, oh, we have to wait to install or reinforce the grid in order to start the electrification of the roads. But what we are trying to show is that you don't have to wait that long. You can actually find a intermediate solution by using stationary charge or stationary storages. So this will be done on this section next to the ancient wall of Visby. The other project is ongoing is in Tel Aviv, where we are installing a 600 meter installation, and there we also will have a bus running, and we actually finalized that installation. Very interesting to compare the two installation sites. On Gotland, we can basically work 24/7. In Tel Aviv, which is a highly dense populated area in a real urban setting, we had to do it overnight. So we installed it overnight. So and also that's also interesting, of course, that the temperatures at night, it was 30 degrees, and that's not really the case on Gotland right now when we are doing the same. But it was also an interesting test to see that we can actually speed up the installation that fast. Then the next project is in Germany, where the large utility company EnBW has bought our technology to operate a bus line between their training center in Karlsruhe to the public train station. And I guess we find this very important because it's a commercial contract. It's not funded by some external party, and of course that means that we have gone through all the discussion in order to go forward in terms of technology readiness and so on. We see a huge interest from many parts of the world, and just to mention some of them, we heard about the upcoming pilot in Sweden. We have there are ongoing discussions in Israel to build a bus line. We have a quite large interest in Germany. Also, there are some quite long or serious discussions in Italy about a toll road, and California, of course, when it comes to clean transport, is also always important player. Just to mention some details about, since it's a Nordic conference, the Swedish pilot, the Swedish Transport Administration has identified 2 different stretches, either Örebro-Hallsberg or Nynäshamn-Västerhaninge. 2 highway sections in different parts of Sweden, where they are now investigating which one to choose. So the first step will be to pick which route they will use, and then the next time will be to most likely make a procurement of the technology. So this is, of course, an important next step for us to be a real competitor in this procurement. And with that said, I would like to thank you and be happy to answer some questions.
Okay, thank you very much, Håkan. So we have a couple of questions coming in here. Let me see, there we have, we start with this one. So what costs would apply to modifying existing e-vehicles to e-roads charging if they can be modified? So retrofitting.
Yeah, so what's interesting, so we are now building our 3rd bus. We are buying the bus from Higer, which is a very large electric bus manufacturer in China. And this 3rd bus is actually cost neutral compared to a standard electric bus. The only additional cost is our components. So in terms of the delivery from the bus manufacturer, there is no added cost.
Okay. And in connection to that, is it possible then to retrofit normal cars to run on your roads?
So theoretically, yes, as long as they have a battery or they are electric cars. But in practice, you would have to we would have to provide a charging interface that can be used and that you can connect to. And today, there are no open charging interface available on typical electric vehicles. But it's a very easy task to really do, but that needs to be done.
Okay, good. Then we have another question here regarding how much power transfer do you assume between road and a bus or a truck?
So for for this truck in the picture, we transfer 125 kilowatts, and that means about 25% more than it consumes in average.
And then we have a final question here online. What is the impact of the road strength?
The road
strength when you are milling and
so we right now we have found a solution that is according to EN standard. So we are actually using drainage channels that are already existing for road construction, and instead of kind of debating if it's a valid solution, we thought let's pick a solution that is already validated. So we believe that by using this standardized solution, we don't see an issue.
Okay.
And I guess the question that was posted before, so a 2+2 highway in regular environment, so no hills or just plain road, is about 3 million euros in Sweden. 2 ways.
All right. Yes.
Per kilometer.
And then if you want electric road, it's plus 1 million then.
Yeah. Basically.
Okay. Good. I don't see any more questions over here. So I think we can conclude your talk. Thank you very much, Håkan.
Yeah, thank you.
Applause in the auditorium.